On this video, we're going to go over the first part of the circuit notes. So we're going to start off with current. When an electric charge flows from one place to another, we say it forms an electric current. Current is the amount of charge that passes a point in a given amount of time, and it's measured in amperes or amps for short, and it's abbreviated with a capital A. For types of currents, we have two types. We have direct current or DC current, if you want to be repetitive with it. It's the current always is going to flow in the same direction, like in a circuit with a battery. So like your calculator has batteries in it, and the current's always going to flow in the same direction through it. For AC current or alternating current, it's going to switch direction back and forth. For instance, electricity that's in your house, that when you plug something in, is going to have alternating current because power plants generate an alternating current. In circuits, the electric current is going to flow in the opposite direction of how the electrons move around. So in this very simple diagram here of a battery and a light bulb, your flow of electrons is going to go towards the positive end of the battery and then out the negative, but then the direction of current is going to go towards the negative and out the positive. So they are just backwards of each other, right? Next up is voltage. Voltage is the pressure from an electrical circuit's power source that pushes the charged electrons through it, or the current through it. So it's like how much pressure is behind it. This is measured in volts, abbreviated with a V. So that's an easy unit to remember. A voltage is volts. This is called potential difference in the physics world. And we'll talk about that, I believe, on the next slide as well. So then we have resistance. The collisions between electrons and atoms in a wire cause a resistance to the electron's motion. So as their electrons are moving around, they collide, and this creates resistance, or if you think of it kind of like a friction. So resistance is a measure of the degree of which a conductor resists the movements of electrons, or how much like friction there is between them. So it's measured in ohms. It's named after the guy that figured this out. And then equivalent resistance is the total resistance in a circuit, and we'll get to this on the next set of notes more, but just remember that definition for now. A resistor is a small device used in electric circuits to provide a particular resistance to a circuit or to a current. So for like electrical engineers or people making circuits, they may want to put in a certain resistor to do certain things within that circuit. Right? I am not well read in the electronics world, so I don't know too much about the specifics for that. But anyway, Ohm's law. To move electrons against the resistance of a wire, it's necessary to apply a potential difference, aka a voltage, between the ends. So to push that current through, all right, we need some voltage or oomph behind it. All right. So Ohm's law, this guy here is Ohm. It relates the applied potential difference, or the applied voltage, to the current produced and the wire's resistance. So it's how all these three things are related. All right. So the formula is a really easy one. It's voltage equals current times resistance. So voltage V equals IR is the short way to write that. They use an I for current. I never looked into why they picked that. It just is what it is. All right, so let's do an example. All right, how much voltage is in a circuit with 100 ohms of resistance and a current of 40 amps? So we're going to plug in what we know. We got our formula. We plug in the 40 for the current. That's I. For R, we plug in the 100 ohms, and we are going to multiply those together and get 4,000 volts. So that's pretty easy to do. Right? Last thing for this set of notes is electrical power. The power formula is really easy. It's P equals IV, or power equals current times voltage. There are some other versions of or other ways to solve for electrical power. I just wanted to stick with one formula for you guys. But if you Google things, you'll find some other versions of this. But anyway, you're going to just multiply two things, and then the unit for power, just like when we talked about power in the last unit, is in watts, abbreviated with a W. So let's do an example real quick. We've got how much power is generated if 40 amps of current flows through a 30 volt circuit. So we've got 40 amps, we plug that in for I, and we've got our 30 volts, plug that in for V, multiply the two, and we get 1200 watts, right? So all in all is pretty easy to do, right? But let me know if you guys have any questions.